Hey guys, it's Eric Weingartner with Weingartner Racing with another product review video. This one's over another one of my Dragon Slayers. Yes, this one's different. If you keep seeing them, it's because each one's different. I will probably never do another one where it's the same head. I mean, it's the same head, but something's done different with each one that I've shown. This one is my 242 standard with the wing, and I'll show you what the wing is. And I even got some footage on me flowing it, trying to spray dye in it and see what it does. But this one's a little bit different than the standard one because you've seen it before. This one, what I've done is, this one has a 2125 intake valve and a 1575 exhaust valve. Now, usually I don't do it in my 242s because the pinch is already small, so making the valve bigger really doesn't do much for it. But in this case, it did something a little different. The customer was like, yeah, let's try some different things. So it changed some things. So it does have a 5/16 stem on intake, 11/32 on the exhaust. It keeps the valve train lighter. It has a 50-degree valve job on both the intake and the exhaust. That seems to work good for this. And it's pretty big. The thing that's a bit different for this is I call it the bastard opening because this is a 1206 wide. So going across, it's 1206. Height is a 1207. This does give me more area at the pushrod pinch. Now, there is a downside for this. And one of the downsides is I don't often do this because of intake manifolds. Many intake manifolds fit a 1206, but do not fit a 1207 without having to do some welding. And let's face it, if I sell a set of heads and you ain't got the intake manifold, you're not going to be one to go out and have it welded. Not to mention, it's not just welding. A lot of people think it's just the welding part that happens. Once you weld a manifold, you have to redo the faces of the manifold so they're flat again. And if you don't, they're warped. And I promise you, they're warped. I've had enough welded and milled enough after being welded to know, yeah, they're warped. You may not know it if you just bolt it on, but they are. So anyway, that's one of the downsides. The benefit is, because it's a 1207 tall, I've got more area at the pushrod pinch. How much area? This is 2.71. If I just kept the 1206 entry, I'm usually at a 2.63 minimum cross-sectional area. And this still runs a stud mount rocker. You do not have to have shaft rockers with this. You can see the notches are the same from Brodix. That hasn't been altered. So you can still run a stud mount. Got a pretty good area so you can, for bigger engines or engines that turn more RPM, you can take advantage. Now, it's not as big as it needs to be for much larger engines or engines that turn more RPM, but it's definitely bigger than the 2.63, so it does help you on larger cubic inches or with more RPM. It's still not as good as having my shaft mount system where I move the rocker, where I move the push rod slot over, and you get more area this way. It exposes more area of the valve. It's better. Anyway, you see that spot? That's the wing and the floor. There you go. Hopefully you can get a view. This kind of helps with airflow slightly, but it does some things with wet flow as well. At some point, I'll do an in-depth video on that. I just don't know when, because probably as you're watching this, I'm on vacation. I did take, though, and you're going to enjoy this, I flowed the head, and I'll show you flow numbers in just a minute. But as I was doing it, I've been working on the LS test head, and you've probably watched some videos on that. And one of the things is spraying some Dykem into it. And I've sprayed some Dykem in this port to see what it would do, because I was slightly curious. I have a slow motion video of that and a little bit after it so you can see what happens, because it's interesting, I'll tell you that. Anyway, that's the head. It's a nice head. Let's look at the flow numbers and then I'll show you the video of the Dykem test. Here are the flow numbers. And this is from my Sanyez bench and this is from the Superflow. The Superflow makes me feel good about myself, but the numbers are higher. The Sanyez is what I use most of the time. I mean, all my research and development takes place on the Sanyez because it flows quicker than the Superflow, but the Superflow does read higher. Same head, didn't change anything. Simply unbolted it off one bench, put it on the other. Anyway, if we look at the numbers, the ones I care most about are 4, 6, and then peak. That's the ones I care about. At 4, it's 254, which is pretty good for a 23-degree head. At 6, it's 318, which is pretty stout. And then at peak, it's 339. Now, I know no one's going to say, well, you ain't got a cam that goes that high. True, but it tells me how stable the port is. And if you look, there is a little dip here at 9. Part of that's because Brodix leaves this notch out here to give the more support for the spark plug. And I could remove it and that'll take care of that, but then there's less support there and the threads of the spark plug are kind of exposed. I don't like it. Anyway, that's what that is. Let's look at the Superflow though. So there's numbers. Oh, and let's look at the exhaust. Exhaust is always strong in my Dragon Slayers, always strong. Even though this is a smaller exhaust valve at a 1.575, it's still got great low lift number, 203 at 4, and that peak at 254. And this is all without an exhaust pipe. This is flowed on a 4155 bore. This is from the Superflow. So the 4 number, 262, 600 number, 326, peak 347. By the way, you've noticed it doesn't have that little dip that the Sanya's does. Because the Sanya's bench reacts faster, its motor controller, it will pick up these little, where it will make a dip that will not show up on the Superflow because its motor controllers react so slowly that it's already kind of stabilized itself, while this one will catch it when it's not stable. The exhaust goes down a little bit on the Superflow. The intake's always higher, 196 compared to the 202, and peak 250 to 254. So overall, really, really good head for a stud mount rocker head, 23-degree deal. Pretty good. All right, I'm going to show you the video of me flowing with some Dykem, and then you hear me talk about it. And then I'm probably at the end of this video, I should have mentioned this, I'm also going to do my product review of my ported Supervictor manifold. I've been keeping it. It's such a short video that I might as well just tag it on this one instead of making a whole new one because it won't be long enough to count for anything. Anyway, yeah, so keep watching. Hey guys, this is Eric Weingartner with Weingartner Racing. A little quick video here for you maybe. I don't know how I'm attaching this to whatever. I have been doing the Dykem test on the LS head where I'd spray a little bit of Dykem in and let the port take it and see how it looks, like where it was going. And I'd done a slow motion video and you can go back and watch it. I have no idea how to link it, but it's in the last one. Well, anyway, I just got finished doing at least one of these, my Dragon Slayer heads. And this one's the one that's got the wing, and I'll show you that in just a sec when I flip it over. But I sprayed some Dykem in to see what it did. Now I'm gonna go ahead and start off by saying I'm gonna attach the slow motion video. I had to spray like 4 times to get anything. So the first 2 only left, it looked like, just like what you see there, this is the head bolt tube. Looks like it hit there and you see a slight line here. Then when I started really spraying, then you start to see it a whole bunch here to there. There's nothing else, none. Now, I do want to point out this, though. Look at the ridge around the whole chamber. This is the cylinder bore. You can see traces where there's still some that's pulling up and going around. So that's moving throughout this. Now, it's probably not the best view, but that's exactly how it is. Okay? The LS didn't do that. They didn't have this ring at all. It had a big old spot on that side, and that was it. Now, I didn't dimple it or burr it besides right here. This is all I ever burr on an intake port. It's from the throat just about 1/4 inch down. That's all. That's it. I left the angle sharp. Maybe that's why it does what it does, because it for sure is, as you can tell, it's only there. And the only reason why I even think it's there is because it's just enough air ramping or hitting that head bolt tube and splashing this way. You could do something called a port intruder. That's where they drill this out and there's a flat wall that's between there and there is no more head bolt hole because the head bolt's like right this big and you ream out that hole and there's like a aluminum slug that sits in between. So you use like a regular head bolt that's only short and it bolts in here and the sleeve goes around it and you port it and then the wall will be smooth. If I did that, it'd be like this. You could say, why don't you just leave it off and have the gaping hole? On the big holes like this for the 7/16 studs, I have seen it pick up power having the tube in. So it does flow more with the tube out. But on a live engine, for whatever reason, the 2 times I've done it, they picked up. So anyway, there's that. Just thought I'd show you it. But let's show you what the wing looks like. And sorry, sitting on, there we go. It's got a lanyard. There you go. See the wing on the floor? There you go. That gets you an idea what you're looking at. I'm getting ready to go float on the super flow, but I gotta clean all this Dykem out. You can see it in here where it hits the head bolt sleeve and then splashes that way. This looks like there's some on that far side, but that's just a shadow. So anyway, just thought I'd show you that. I'm gonna float on the super flow after cleaning this off, otherwise it's gonna flow worse because you see that little glob is right on the valve job. That'll reduce its flow. Boom. Interesting anyway. Just thought I'd share that with you guys. I do plan on, because I know some people have asked this, why are you doing it this way? Why don't you bolt the intake manifold on? Good news. I'm going to be porting a manifold that fits this. And what I'll do is I'll bolt the head to the flow bench. I'll bolt the manifold and I'll do it again. And then I've got a throttle body, but it's a 4150, so I'm going to have to use an adapter. Maybe not. I might have a 4500. And I'll try it again and we'll see what happens. I bet you we see the Dykem more in the intake manifold than we do anywhere in the head. But anyway, that's later on. Just thought I'd show you that, get you some ideas. Hey guys, this is Eric Weingarten with Weingarten Racing. This is a product review video, and this is over an intake manifold I just finished porting. This is the Edelbrock Supervictor 565. I think the part number is 2896. Yep, 2896. Anyway, these ones are almost impossible to get now because Edelbrock has a problem putting on any type of production. But these, when ported, work pretty good. So I like them. I do think that there's probably ones that might be a little bit better. For instance, I think a Sniper ported it ends up better than this. But I used not to believe that, but my opinions have kind of changed as time progresses. The reason for that I don't like about this manifold, and I'll go through it. Of course, I ported it. It's got plenty of cross-sectional area. That's great. Both of them. The line of sight's not that bad either. Some people, which I would, if there was more extensive porting, what I would do is I'd mill this back at a 45 so it actually breaks through, weld here, and make the plenum bigger and make that shot straighter. But this one's already powder coated when I got it, and for what he's doing, he doesn't want to invest that amount of time or money into it. But as it is, ported were pretty good. Now, I'll go through a couple things. I actually left the floor rough just because it helps with the fuel atomization. I don't leave it rough anywhere else. If the fuel's gonna fall out, it falls down and it's gonna get picked back up in the stream. So that's the reason why I leave the floors rough. Sometimes I don't always do that. I'll leave it just rough right there, but it kind of varies with each one. So the rest of it's, this is 60 grit. So that kind of helps things. Anyway, here's what I don't like about the manifold. The manifold itself, like maybe this view will give you a better indication. It's the way it enters the runner. So the runner's right here, the top, the roof is the worst part. It enters, it comes almost like a straight slant into it. So in other words, the head's like this, the manifold's like this. So it's entering this way right into the port. So it's slamming in like this and into the port. Not the most ideal situation. So instead of having it, you'd want the port to kind of taper gradually this way. Instead what you have is you have the manifolds like this, and then it goes to that. So that is what it's happening. So it causes it to not perform as well as it should. The Sniper Junior comes off the head and comes in a straight path, and it's much better. So I like that better. Anyway, this is the manifold that I showed off real quick. Give you something to talk about. I'm gonna probably tag this on to some other video. Anyway, you guys take care.